Hello everyone. Okay, today we're going to talk about the computational complexity for the problem exchange sort. Okay, so before we talk about analyzing the insertion sort, uh, calculate the worst case and average case time complexities for when we are considering the number of assignments, also when we are considering the number of comparisons. So here we are going to see that what's going to be the time complexity for number of assignments of records, okay, done in the exchange sort. So again, the number of assignment we have here, okay, for every iteration is equal to that swap that we have here. So we have these swapping values of SI at location I and S at location J. So exchange sort is really easy, okay, for every item location I, and then you are comparing with all other numbers that are the upper indexes. And if that number, okay, is bigger than those numbers, so we are moving them to the right. So big numbers go to the right, okay, they are shifting to the right or the very end of the array, and the smaller ones remain and stay at the lower indexes. So that's really easy and primitive way to sort numbers, that is exchange sort. So it's not hard to see that the swap function does 3 assignments. Okay, so we need some temporary value. Let's say that we are calling it t. So you are saying that put s at location I to t, and then you are saying that s at location I will be s at location j, and then you are finally saying that s at location j is equal to t. So every swap operation has or does 3 assignments. So keep that number 3 in your mind. And now let's gonna see that what's gonna be the worst case. So the worst case happens is that this if it's always true. So that that if condition always holds. So for and see that what's gonna be from I equal to n, from I to equal to 1 to n, and from j plus I plus 1 to n. So let's assume that we're going to do it with some examples. So let's assume that I is equal to 1. So j starts at I plus 1, that is equal to 2. And it goes up to number n. And then again here, indexes are stored at 1. Okay, so the first value of the array is located at location 1. So that's why here we have I equal to 1 and not equal to 0. So it goes from I equal to 1, j goes from 2 to number n when I is equal to 1. That if we see that, and we are saying the worst case is that we're having this if condition holds for all cases. So if this is the case, okay, this for loop, inner for loop, okay, gonna go from j equal to plus 1, that is 2 to n, that is gonna be n minus 1. Okay, so that's the number of items and a number of times that we are doing the if we are inside this for loop. Then we have also when, let's say now assume that I now becomes 2. Okay, now let's say that I becomes 2, so j start with 3. So we'll have j goes from 3 to n, and again worst case is that we're gonna have all if condition holds. Okay, so it's gonna be n minus 3 minus plus 1, that is gonna be n minus 2. So if you just continue this one, okay, so when I is equal to n, and we can easily see that this is a very simple summation, okay, that's gonna be I equal to 1 to n minus 1 of n minus I. Okay, and the reason that we are going to n minus 1 and not n, because when n is equal to I is equal to n, okay, then the second for loop, okay, doesn't hold, because it says that I equal to j I plus 1. Okay, so it's gonna be n plus 1, so that is not less than n. Okay, so that's why we're going to n minus 1, and this is gonna be equal to n multiplied by n minus 2 and divided by 2. But this is the number of times, okay, we are going and having this inside this for loop. And we said that it also every if condition holds, so, and we are doing free like the swapping or free assignment, sorry, we are doing free assignments. So we multiplying this number by 3, and this is gonna be the worst case for the number of like the assignments in exchange sort. So it's not, again, it's not hard to see that. Okay, I have shown this for the insertions sort for the number of assignments in the average case. Okay, and as you remember, I said that for that you need to say that what's gonna be the average case, okay, for this when this condition holds, okay, because we, in the worst case, we said that this condition always holds, so it means that we'll have 3 swaps for every like the iteration, inner iteration. So in the average case, okay, it might be case that you know, sometimes it's like the S of I is not less than S of J, and so we can see that how many assignment we'll have. And again, if we consider also that the distribution is normal, so we can have a like the same probability for all these values that we have here. Okay, so again, we can find the average case. But the average case, okay, the solution will be 3 divided multiplied by n minus 1, and divided by 4. And again, it's not easy, it's not hard to see that, and that's number 3 comes from that swapping function I have here, and this n okay, as also this is almost is approximation. So n multiplied by n minus 2 divided by 4 also comes from getting the average of the number of assignments when based on the comparison of S of at location I and S at location J.